Hello everyone, it's 𝗕𝗲𝗶𝗵𝗺 from Tek Caffe. Today I'm going to talk about simple design, what it is, its properties, the rules of simplicity, and its anti-patterns. So let's start first by describing what simple design is. Simple design was originally a core XP practice or extreme programming practice that was described in early writings of extreme programming, like Kent Beck's first edition of Extreme Programming Explained, Embrace Change. The practice promoted the idea of implementing the simplest design that would work today and worry about the future when the future comes. So we can notice here that it's promoting the concept of decide as late as possible or decide at the last responsible moment. And Yagni, you aren't going to need it, because we are basically doing design that would just meet today's requirement and would be simple enough to change in case we have future requirements. But it doesn't address the needs for future requirements, because these requirements may get cancelled, and there will be no justification for the complicated design that was made to house or accommodate these future requirements. So that is simple design, and many people think that because we're doing the simplest design possible, that this design is eventually going to end up being a mess. No, we're just saying that simple design is basically doing the simplest thing possible today, and that we shouldn't be doing anything more to address anything that is going to come in the future. But that doesn't mean that this design is not going to be following software design principles, design patterns, clean code guidelines, etc. No, it's still going to follow those, but it's going to just address today's needs and is going to be easy to change or cheap to change in the future. So what are the properties of simple design? The first property is that it should meet the rules of simplicity, which I'll be talking about later in this video. The second property is that simple design is incremental and evolutionary. And it's good to mention that in the second edition of Extreme Programming Explained, simple design has been renamed to incremental design. Because as we've said, yes, it is simple enough to meet what we need today, but it should be easy to change and cheap to accommodate changes of the future. So it's going to evolve, and in an incremental and iterative manner. So this should be one of its properties. The third property is that simple design is easy to change and the cost of its changes is cheap. The fourth property is that simple design is easy to understand. The fifth property, simple design is easy to test. And the sixth property, simple design is design which we have came to based on the principle of decide as late as possible or take the decisions at the last responsible moment. Okay, so we've said that one of the properties of simple design is that it adheres to the rules of simplicity. So what are the rules of simplicity? The first rule is that the code is verified by automated tests and that all tests pass. So as we can see, the rule promotes test first or test driven development, and promotes test-driven development using the red-green refactor mantra, because in test-first approaches, the time when we do design is the refactor phase. So after we've written a failing test, then written just enough code to see the test pass, we then start worrying about the design in the refactor phase. The second rule is that code should have no duplication and applies the dry principle. The third rule is that the code expresses separately each distinct idea or responsibility. So here we're talking about code that is highly cohesive, applies the single responsibility principle, and applies the concepts and guidelines of clean code in terms of the size of the methods, the naming, etc. The fourth rule is that code is minimal. It has the fewest number of lines of code, methods, classes, etc. And here we're basically talking about the Yagni principle. You aren't going to need it. So we are writing just enough code to make our tests go green and meet our requirements. We're not writing anything more that we don't need today. So these are the rules of simplicity, and if you follow these rules, you will surely have a simple design. Now, if you read the C2 wiki, you will find that there is another version of these rules where the second and the third rule are replaced with low coupling and high cohesion, which is perfectly fine, and you can work with both versions of the rules. Let's talk about the anti-patterns of simple design. Two anti-patterns: over-engineering and no engineering. So over-engineering is the case where you have too many design patterns that you don't need, you have too much code that you don't really need, and that is basically addressing requirements in the future that may or may not come. So yeah, over-engineering is basically an anti-pattern of simple design, and simple design was actually meant to address this common anti-pattern. The second anti-pattern is no engineering. Sometimes the design is extremely simple that there's no design at all, there's no engineering at all, there are no principles, there are no patterns, there is simply nothing. And this is where you end up basically with legacy code or dirty code or rotten code. So this is another anti-pattern. Simple design is supposed to be good, clean design, and there has to be some engineering in it. It's not meant to be, no engineering at all. So that is it. Simple design, its properties, the rules of simplicity, and its anti-patterns. Hope you've liked this video. Don't forget to subscribe to my channel, like the video, and follow Tek Caffe's LinkedIn page, and see you in a coming video.